Okay, so. Okay, wrecking ball. Wrecking ball question, right? We have a wrecking ball that has a mass of 50 kilograms. Okay, and it's suspended by a cable. So let's draw a series of pictures. So here is the wrecking ball. Okay, this cable is 10 meters long. Okay, now we have it set up against the wall. So it kind of looks like this. So this length is 10 meters. The angle with the wall is 30 degrees. All right? Okay, so when we pull the wrecking ball back, what kind of energy does it have? What's its initial energy? What is it? Yeah. And how do you calculate that? So it's potential energy, which is mg. Yes, mgh. Okay. Now the thing is, we know that the cable is 10 meters long, so that's a fixed length. But now the question becomes, well, how much did its height change? Okay. So what we can do is something really simple. We know that if the cable was just straight, that this length over here would be what? This would be 10, right? But it's pulled back, which means that it's actually, its height has changed. Okay? We can figure out how much its height changed by using just some simple trigonometry. So what we're going to do is we're going to convert this to a triangle, and we're going to look for this component over here. Okay? We're going to look for this component from here to here. Okay? So what is this component? What is this component, this y component? What is it? So it would be cosine 30 times 10. That would be about 8.67, I believe. So if this is 8.67 and the whole length is 10, then we know that the difference must be the elevation. So the difference has to be 10 minus 8.67, or 1.33. The elevation of the wrecking ball must be 1.33 meters. Okay? So now we can figure out the potential energy of the wrecking ball, because we know it's mgh. So we can go ahead and calculate the potential energy. So the mass is 50, G is 9.8, and the potential energy, the height is 1.33. So what would that be for potential energy? $650. So we'll just say 652. So 652 joules of energy. Okay. When the wrecking ball is released, we know it's going to swing down, and its maximum speed will be where? Upon impact, right here. Okay? This will be its max speed. We could say then at that point that the kinetic energy at the bottom, so we could say the kinetic energy at the bottom should equal the what? Potential energy at the top. So if we know the kinetic energy, if we know the potential energy at the top is 652 joules, we can figure out the speed, because what's the formula for kinetic energy? It's 1/2 mv squared. So what we can do is we could say, well, let's solve for v. V will be 652 times 2, get rid of that 2, and then we divide by m, which is 50. We'll take the square root of that, and we can get our speed. of impact. So what would that be? What would speed of impact be? 5.1? 5.1 meters per second. So that's how you get the speed at its maximum point, which is through that rest position. In this case, through that point where the wrecking ball hits the wall. Now, if you want to know, because there is a follow-up question here where it says, so we have the speed of impact. Now, if the wrecking ball goes through the wall, imagine it goes right through the wall, so it has enough energy to actually push right through this wall. And what ends up happening is it makes an angle on the other side. So it makes this angle, okay, which is 15 degrees. So this is 15 degrees. Okay, how much potential energy would it have? Because what's going to happen is the wrecking ball goes through the wall, it goes up, and then it's going to stop. So we can figure out the potential energy in this scenario. So what would the potential energy be at 15 degrees? Well, we can do the exact same thing we did before. We can say, well, we have a triangle here. And we know that the triangle, the hypotenuse is fixed because it's the length of the cable. We know that's 10. So what we could do is we could figure out what this is. So y would be what? Cosine 15 times 10. That would be what? What's cosine 15 times 10? 9.7 meters. That means that the difference would be 0.3 meters, right? That difference, that change in height is 0.3 meters. So now what we could do is we can say, okay, well, what's the potential energy at 15 degrees? Well, the potential energy would be what? Oops, sorry. It's going to be mgh. So it's 50 times 9.8 times 0.3. So what would that be? 147. Okay. Now you'll notice that the amount of energy is less, and it should be less, because what happened? Where did some of the energy go? Into the wall, right? To actually break the wall. So vibrating the wall, cracking the wall, sound energy, heat energy, right? So a lot of that energy is lost. Now how much would be lost? That's easy. It's just a difference between the two. So the energy lost would just be the initial minus the final. So the initial energy was 652. The final energy is 147. So the energy lost by the wrecking ball is what? This is by the wrecking ball. What's the energy lost? Sorry? 505 joules. Okay? Now, where did that 505 joules go? Well, into the wall, generating heat, generating sound. So it's not really lost. It's just been converted into some other form. Okay? So that's how you would do a wrecking ball scenario. That's how you would calculate potential energy. That's how you would calculate kinetic energy. That's how you calculate speed. Okay? Very, very basic stuff. And that concludes this presentation.